Alright, so in this question, they're suggesting that a Carnot engine operating between temperature T1 and T2 has the efficiency of 1 by 6. When the temperature T2 is lowered by 62 Kelvin, its efficiency becomes 1 by 3. Okay. The temperature T1 and T2 respectively are going to be what? Okay. So look here. Basically, in this question, they're saying that you have a Carnot engine. Okay, and you have a Carnot engine which is operating between temperature T1 and T2. So your source temperature is T1 and your sink temperature is T2. Okay, and with this T1 and T2, you have an efficiency, eta is equal to 1 by 6. Fine. Now, when you decrease the temperature to T2 by 62 Kelvin, your efficiency becomes 1 by 3. Okay, you have to find out T1 and T2. So what is happening here is, as you are reducing temperature T2, right, what you are doing is you are reducing the wastage, that this Carnot engine is throwing out, right? Basically, the amount of energy, the amount of heat that the engine is able to use is going up, right? The efficiency is going up, or you can say that the amount of wastage is decreasing. Okay, so this is what you need to understand. Let's write down the mathematical equations. So eta is nothing but 1 minus T2 by T1, okay, or T1, 2 minus T by T1, whatever you want to call it, okay, and this is equal to 1 by 3, right? Sorry, 1 by 6 initially. Now, when I talk about, this is eta 1, when I talk about eta 2, my second efficiency that's given to me as when I reduce T2 by 62 Kelvin divided by T1, this is going to be equal to 1 by 3, okay? From here, you have two equations, two variables. Of course, you can solve this. Okay, so let's see. So this will become T1 minus T2 by T1 is equal to 1 by 6. Or actually, let's write it like this. Let's write it as 1 minus 1 by 6 is equal to T2 by T1, which means 5 by 6 is equal to T2 by T1. Or I can write it as 5T1 is equal to 6T2, right? Let me write this properly. 5T1 is equal to 6T2, and this will be my equation 1. Okay, cool. Now, let's sort out this eta 2, and then we'll see, we'll also find the corresponding relation. We'll combine equation 1 and 2 to get our temperatures. So, let's see what we have here. So, here we have 1 minus 1 by 3 is equal to T2 minus 62 by T1, right? So what do you get here? You get 2 by 3 is equal to T2 minus 62 by T1, or you can write it as 2T1 is equal to 3T2 minus 62. Okay? Okay, this will be 3 into. Okay, cool. So now what do we have? We have 2T1 is equal to 3T2 minus 3 into 62. So you have 180 plus 6, that is 186. Okay, this is what you get. Now, this needs to be substituted in this. Okay, so what will we do? We'll write it as T1 is equal to 6T2 by 5, or 6 by 5 T2. So we'll write this as 2 into 6 by 5 T2 is equal to 3T2 minus 186. So now you have one equation in T2 which you can most definitely solve. So what do you get here? You get 12T2 is equal to 15T2 minus 186 into 5, right? This is what you're getting. So basically you get 3T2 is equal to 186 into 5, or you can write it as T2 is equal to 186 into 5 divided by 3. Okay, now this 186 we just wrote it as 62 into 3, right? So this will become 62 into 3 into 5 divided by 3. So you cancel that out. This is 62 into 5, which is nothing but 300 plus 10, 310 Kelvin. This is your T2. Let's find out T1. How can you find out? You have an equation 5T1 is equal to 62, right? So 5T1 is equal to 6T2, which means T1 is equal to 6 by 5 T2. We've already written. So 6 by 5 into 310 Kelvin. Okay. So let's cancel it out. This will go once and this will go 62 times. So 62 into 6. This is what you're getting. So basically 360 plus 12. So 372 Kelvin. Okay. So I got T2 is equal to 310 Kelvin and T1 is equal to 372 Kelvin. Right? Which is here in option D. So option D is going to be the right answer to this question. So here in this question, they're saying the number of photons of light, of course, the number of photons of light having wave number x in 10 joules of energy source is going to be what? All right, cool. So let's see. So basically, they've given you wave number. Wave number is equal to x. E is given to you as 10 joules. You have to find out what is n. Okay, see. What is the formula that we're going to use? We know that E is equal to hc by lambda. Okay, you know that wave number nu bar is equal to 1 by lambda. Correct? So this nu bar is given to you as x. So this thing will become hcx, right? However, we need to talk about number of photons, right? So this energy equation is for one photon. So now total energy E total will be nhc by lambda. So instead of by lambda, I'll write nhcx. Okay. So you get nhcx, right? Now, total energy is given to you as 10 joules. So which means 10 is equal to nhcx. So you have to find out n, which is nothing but 10 by hcx is equal to n. Simple, right? Okay, so what did we get? We got 10 by hcx, which is here in option C. Okay. Alright, so here they're asking which of the following series is arranged in order of increasing ionic radius. Okay, cool. What are the species in question? Let's see. You have Mg2+, you have S2- sulfide, you have chloride, you have potassium+, and you have calcium 2+, right? Okay, so what we're going to do first, we're going to write down their atomic numbers. So the atomic number of magnesium is 12, of sulfur is 16, chlorine is 17, potassium is 19, and calcium is 20. Okay, these are your atomic numbers. Now let's talk about the number of electrons in each of these ions, right? So what happens here? So here you have magnesium 2+, which means 2 electrons are kicked out. So here you have 10 electrons. Okay, sulfide. Okay, so S2-, you have 16 plus 2 electrons, so this will be 18. Here also chloride plus 1 electron, so 18. K plus, so 19 minus 1 is also going to be 18. Calcium 2+, again, you have 18, right? So you can see, apart from magnesium 2+, all of these are your isoelectronic species. And magnesium 2+ has only 10 electrons, which means you are talking about basically one less energy level, one less shell. So yes, magnesium 2+ is going to be the one with minimum ionic radius. So I'm going to discard options C and D immediately. Magnesium 2+ is the least. What after that? Okay, so let's see. You have isoelectronic species, right? So you have isoelectronic species, which means their number of electrons is going to be the same. Okay, what is going to change is going to be your effective nuclear charge, right? So depending on your number of protons in the nucleus or the charge on the nucleus, your ionic radius is going to differ here. Okay, so as your charge on the nucleus increases, or number of protons or atomic number. So if your Z is increasing, then you know that your Z effective is also going to increase, because you are talking about isoelectronic species. And as your Z effective increases, you know that your ionic radius is going to decrease. Okay, why? Because your nucleus has a higher charge, right? So it's going to pull the electrons more strongly, because of which what happens, they're going to come closer. If they come closer, then the radius of your given species, be it ion, be it atom, whatever it is, of your given species is going to reduce. Okay, now where do you have the highest atomic number? The highest atomic number is in Ca2+. Okay, so Ca2+ will have the least radius. Okay, followed by what? Followed by K plus, followed by your chloride ion, followed by sulfide. And of course, you had your magnesium 2 plus here, which is anyway minimum. Okay, so now let's look for this order. You have magnesium 2 plus as least, followed by calcium 2 plus, potassium plus, chloride and sulfide. So option B is going to be the right answer. A can be discarded. Option B is going to be the right answer to this question. Alright, so here they're asking which of the following statements concerning a covalent bond is false, right? Okay, let's see. So you have 4 statements. We'll read whichever is true, we'll mark true, whichever is false, we'll mark false. And wherever we find false statement, that statement is going to be our answer. So let's see. You have option A. The electrons are shared between atoms. Okay. So the electrons are shared between atoms. This is how we actually define a covalent bond, right? In an ionic bond or in an electrovalent bond, what happens is the electrons are transferred completely. But in a covalent bond, both the atoms, right? Both the atoms that are involved in bond formation are going to bring their respective electrons, and that pool of electrons, right? That pool of 2, 4, 6, whatever it is, depending on the number of bonds formed between them, that pool of electrons is going to be shared between them such that each of them can individually complete their octet. Okay? This is how we define covalent bond. This is how we talk about stability from a covalent bond. So the statement is obviously true. Then we have option B. The bond is non-directional. Okay, so what does directionality of a bond mean? So directionality of a bond is nothing but it talks about spatial orientation, right? There has to be some sort of spatial orientation or specificity in spatial orientation. Sorry, I forgot the spelling. Okay. Orientation. Okay, there has to be some sort of specificity in the spatial orientation when you talk about the formation of the bond, right? There is some selectivity in it. Why am I saying that? Because see, you have, let's say, a p orbital like this, and you have another p orbital like this. Even if they're of the same energy, right? Even if they are both 2 p orbitals, there is no way that there will be a bond formed between this, right? Between, let's say, this is pz and let's say this is py. There is no way pz and py will overlap and form a bond even if they have the same energy. Why? Because of the difference in their spatial orientation. So that is where your bond directionality comes into picture. Okay, so you have to ensure that for a pz to bond, you give it another pz, right? Pz will not bond with py or px. Understood? So that is where directionality comes into picture. And what about S? If I bring one S here, will it bond? Yes, definitely. Why is that so? Because the S orbital is non-directional in nature. Okay? Covalent bonds are directional in nature because of this very reason, right? When you talk about overlap, it has to be in the proper orientation. Okay? So it is directional, which means this statement is false. Then we have option C. The strength of the bond depends upon the extent of overlapping. Okay, let's come back to the same example. Okay, let's say that you have first case, you have a 2pz bond formed. Second case, you have a 3pz 2pz bond formed. Okay, what will happen in the first case? The extent of effective overlap will be more. And in the second case, the extent of effective overlap will be lesser. So here overlap will be higher. Here the overlap is going to be lower, right? The extent of effective overlap is lower. Because of which what happens? It is much easier for me to break the 3pz 2pz bond. If it is easier for me to break the bond, then what can I say? The bond strength is decreasing. So if the effective overlap decreases, then the bond strength decreases. Okay, and in case of 2pz overlap, what is happening? Your effective overlap is more, because of which it is a stronger bond. Okay, cool. So this is what we see, that if the effective overlap is decreasing, then the bond strength will decrease. Strength of the bond depends upon the extent of overlapping. Absolutely true. Then last, option D, the bond formed may be polar or non-polar. So what are they suggesting here? That it is possible that elements of the same electronegativity, or you can say atoms of the same element will form a covalent bond, or atoms of different elements will form a bond. Okay, for example, you know that HF is a bond, right? HF is a covalent bond, and this is a polar covalent bond. However, if you look at H2 or if you look at F2, these two individually are non-polar bonds that we are talking about. Why? Because you have a homodiatomic molecule, right? In case of H2, in case of F2, you have a homodiatomic molecule where you have two hydrogen atoms or two fluorine atoms making a bond. So in that case, why will there be a difference in electronegativity? There will be no difference in electronegativity. So the shared pair of atoms will be in the center, right? They will not be pulled towards any one hydrogen or any one fluorine more strongly than the other. So in that case, it becomes a non-polar bond. Whereas when you look at HF, what is happening? Fluorine is definitely the most electronegative element, so it's going to pull the bond pair of electrons more towards itself, right? So what is happening there? Your bond becomes polar in nature. Okay, so yes, this statement is most definitely true. You see, we have one false statement, which means option B is going to be the right answer to this question. Okay, so here they're asking what is the value of delta U, that is heat change at constant volume, for reversible isothermal vaporization of 90 gram water at 100 degrees Celsius. Assuming water vapor behaves as an ideal gas and delta H of vaporization of water is 540 calories per gram. Okay, so see, what you need to understand is the formula we're using is going to be this: delta H is equal to delta U plus P delta V. Okay, P delta V as in, you know, what is happening in terms of volume of vapor minus volume of liquid. Okay, so here I can write this as nRT. Okay, so once you write this, then everything is more or less, there for you. You can calculate delta H. Delta H is going to be what? 540 calories per gram multiplied by mass. What is the mass given to you? 90 grams. Okay, so when you calculate, you'll get 100 into 54 into 9, right? So this is going to come out to be 54 into 9 is what? 54 into 9 is, 54 into 9 is 6, 3 and then 8, 4. Okay, so you have 48600. So many calories, 48,600 calories. Cool. Then what do you have? You have nRT. You have to do this. So N is what? N is 90 divided by molar mass of water, which is 18. Okay, 18 gram per mole. R, you take it as 2 calories because we are talking about, this in calories, and our options are also in calories. Take this in calories, and temperature T will be 100 degrees Celsius. Convert that to Kelvin. So that is 373. Now you can cancel this out. You'll get 5. So this will be 3730 calories. What was the formula? Formula is delta U is equal to delta H minus nRT, which is 48600 minus 3730. So many calories. Let's quickly calculate. So you have 48600 minus 3730. So you have 0, 10, so you have 7, and then you have 6 here, so you do 5, and then you do 7 here, so you have 484. Okay, so basically you have 44870 calories, or I can write it as 44.87 kilocalories. Okay, so I have 44870 calories, which also I can write it as 44.8 kilocalories. Correct? Now, look at your options. Your option A is saying 9 into 10 to the power of 3 kilocalories. So 9 megacalories. No, not correct. And option B, 6 into 10 to the power of 3 kilocalories. Same again, not possible. Option C is saying 44.9 into 10 to the power of 3 calories. So we got 44.8 kilocalories and we have 87, right? So of course I can approximate this to 44.9 into 10 to the power of 3 because we have kilo anyway. So calories, yes, absolutely. Option C is matching. Option D, none of these is not applicable. So option C, 44.9 into 10 to the power of 3 calories or 44.9 kilocalories is going to be the right answer to this question.